I haven't looked at this since I made it, so you guys are going to have to keep me honest. I'm not going to, I might miss some of them too. I don't know. Maybe. Okay, if cotangent is 5/12, cotangent is 5/12. So what is this 5/12? 13? 144 plus 9. No.
144
plus 81.
minus
Or plus 25.
81.
See what I'm talking about?
144 plus
25.
5 square root of 169. It's
13. Yes. Okay. There we go.
Good Lord.
We're on the easy problem. Okay. Secant is inverse of cosine, so it'd be 13 over 5. Whoop.
It's like, oh, that's not a choice.
Yeah. I did that in my geometry review last week. Got the answer and was like, okay, let's go back. Not quite right. Okay, find the values of the 6 trig functions. When AC is 10, BC is 8, so that means this must be 6. So sine, well, let's just, sine is going to be 3/5. Cosine is 4/5. So let's just find those two. See, I've already messed up. 3 over 5 is sine, right?
No,
Should be 4
over 5 is sine.
Oh, there's theta. Yeah.
It is a good day.
Yep. That's not theta. This is theta. So 4 over 5, so it's one of these two. 3 over 5, so we've gotten this far. Cosecant is 5 over 4, so there it is. All right. If t is 30.1, r is 19, find s, angle s. So we would use what? Cosine? Inverse cosine? And all of my answers are they radians or degrees? Degrees. So make sure your calculator's in degrees. And then go inverse cosine of 19 divided by 30.1. 50.86. Change 250.52 to degrees, minutes, and seconds. Well, 250 is your degree. 0.52, I take 52 divided by 60 is 8.8. Is that right?
Don't you do?
I have to remember how to do minutes to degrees.
52 times 60.
Times 60. That sounds about right. I get 31.2. So it's 31. And then 0.2 times 3600. Oh no, you're right. Times 60 again. 0.2 times 60 again. 12. Yes. Letter B.
Were you right?
I told you. Yeah, you're right.
Okay, that's good. It's just a rough.
It is. Okay, so 47 is where I would start. And I take 47 divided by 3600.
Okay. I didn't know how to do that one, so I just went through these.
And then I'd add that to 21 divided by 60. And then it's 62.363 is what I get. Okay, change 3.94 radians to degrees. So I just take 3.94 times 180 over pi. Because this is radians and radians cancels. 3.94 times 180 divided by pi, 225.74. Change 175 to radians in terms of pi. Oops, pi. I'm going to simplify. So that's 35 pi over, what is that, 90? No, 36. write 5 pi over 30 in degrees. 5 pi over 30 times 180 over pi. 30 goes into 80 60 times, right? 300. Negative 2160. Negative 2160, I'm going to go ahead and just divide that. Subtract 360 minus 360 minus 360. Isn't that just 0? Because 360 goes in that evenly. But no, it's not.
Wait, what if we just do it like the same?
I can. Right?
Why is it pi over 360?
I don't know.
I don't know.
It's a long day already. I'm at 8th period. I've been doing these every period.
2160
Losing it.
divided by 6.
By 180. 2160 divided by 180 is 12. Which is the same as 0. Okay, find one positive and one negative angle, coterminal. 126 is over here. So 180 minus 126, 54. So 54 is your, okay, so that's 126. So if I add 360 to it, I'm going to get 486, right? But then I have to, it'd be the negative 234, wouldn't it? Because I'd go 180 and then another 54. Because all of these are in the 4th quadrant, and that angle's not in the 4th quadrant. Okay. A roller of radius 12.5 centimeters turns 14 revolutions per second. What's the linear velocity? I've got to remember my... Is that the right formula?
This is one of my resource ones.
Angular velocity times radius? Yes. Okay, so my angular velocity, 14 revolutions per second times, this is in meters per second, so my meters is good. Every revolution is 2 pi r, right? Or it's 2 pi, sorry. 2 pi per 1 revolution. It goes 2 pi. Then I multiply that times 12.5 centimeters. But all my answers are in meters. So then I have to multiply that by 1 meter is 100 centimeters. And then cancel my units. 2 pi is unitless. So that should give me meters per second. 14 times 2 times pi times 12.5 divided by 100. 10.99, call it 11. Jake's bicycle tires have a diameter of 22 inches. If he rides 6 miles per hour, what's the angular velocity? So velocity is equal to angular velocity times radius. Radius is 11. So we have 6 miles per hour. These are revolutions per minute. Times radius 11 inches. Times, I want minutes. A lot of times I get my answer just by unit, by dimensional analysis, just trying to figure out what crosses out. And then revolutions, so I want revolutions at the end, so I'm going to say 1 revolution is 2 pi radians. So 6 times 11, this isn't going to work, is it? Oh, I know why. No, I don't. I kind of go backwards with this one. To get revolutions, I started with revolutions, multiplied by 2 pi in 1 revolution, times the radius, right? And I got velocity. This time I have velocity. Oh. He rides 6 miles per, oh, this is velocity, so 6 miles per hour times 1 hour over 60 equals angular velocity, right? So I'm going to take this and divide it by r to get this. So 6 divided by 60 is 0.1, and then I divide that by 11.
Okay, what I did?
Divided by 11
28.
times 2 pi? No. Okay, what'd you do?
So I converted 6 miles per hour into inches per minute,
Inches. Oh, inches, that's my other issue.
and then I divided it by 22, and I got 288.
Okay, so you took 6 miles per hour.
And converted it to inches per minute.
Okay, that's my problem. I still have miles and inches here, so that's not going to work. 6 miles per hour times 1 hour, 60 minutes. That gets me to minutes. Times 1 mile is 5,280 feet. Times 1 foot is 12 inches. Right?
Yes.
Okay, so that's my velocity. Then I'm going to divide that by 11.
But you get 6,336, and then I divided
6
it by
times 5280 times 12 divided by 60. 6,336 is my velocity. And I divide that by 11, and that gives me 576, but that's radians per minute, and I want revolutions per minute, so I have to divide that by 2 pi. Divided by 2 pi. 91.67.
Dang it, I got it wrong.
Because I had to do that final 1 revolution is 2 pi radians. But you got this part right, so I'll give you half for it. It's better than I did. Why am I getting a decimal? This doesn't make sense. Okay. Suppose theta, I think I can do this one. Okay, we're going to try it.
Are we going to finish this there?
No, we'll finish tomorrow.
Okay.
Suppose theta is an angle in the standard position whose terminal side is in quadrant 3. Okay, quadrant 3 down here. I'm so excited I can do this one. I know I can do this one. Okay. Secant. Here's theta. Secant's the inverse of cosine. So that means it's 17 negative 8. Find the exact values of the remaining 5. Okay. 17, 8,
15.
and it's negative. So sine is negative 15/17, and this is the only one. Find the exact value of cosine 780. Well, 720 is going to be 60 degrees in the first quadrant. Cosine of 60 is 1/2.
Yes.
There it is. Are you amazed at how fast you can do sine, cosine, tangent of 30, 60, 90, 45, 45, 90 triangles now?
What?
Somewhat.
Yeah, do we get to use our trick sheets on this?
I probably won't let you use the unit circle, but you can definitely use the formulas, yeah. Exact value of sine of 9 pi over 4. My guess is it's going to be a 45 since it's over 4, but which quadrant? 4 goes into 9, so it's first quadrant, right? It's the equivalent of, because 8 pi over 4 is all the way back to here, and then I have one more pi over 4, and I want sine square root of 2 over 2. Oh, graphs.
I'm not good.
Okay, amplitude is 5. Amplitude's always positive. So right away, I'm done. Negative just tells you if it's flipped upside down, but amplitude's always positive. Is the period equal 2 pi over 7? Yes, because 7 is the coefficient of x. Okay. Oh, what was this one? Right, an equation of the cosine function with amplitude 2 and period 6 pi. So to get to 6 pi, I had to take the coefficient and divide it by 2 pi, right?
Yeah. So it'd be 1 over 3.
So,
Maybe not.
is that right?
Wouldn't you practically divide it by 2 pi divided by 6 pi?
What divided by 2 is 6 pi?
Oh, never mind, you're right.
But what do I shouldn't have 12 pi squared. That doesn't make any sense.
I think we just cross out this line.
Period is 6 pi. So I take the coefficient and divide it by, is it 2 pi over the coefficient? Or the coefficient over 2 pi?
Pretty sure it's 2 pi up to go. I don't know.
Told you I hadn't looked at this since I gave it to you.
I'm telling you, let's opt out of this. I need our less to do this.
So 2 pi over 6 pi is 1/3. So it's going to be this one or this one, and it said the amplitude was 2.
That's what I got for my answer.
I agree. And it had to be that one anyway if I just looked at strictly at the amplitudes,
Sure.
because it didn't say anything about flipping it over the x-axis. Okay. Graph the function. Amplitude's 4. We've got that one. It shifts, vertical shift is up 1. So let's hope, so I'm down to this one or this one. So 2 pi over 3 is my period. Oh, darn it. Well, what's the, oh no, I'm down here. What's the difference in those two? Just the graphs?
Yeah. One of them is closer to the
Darn it all.
line.
So we've got to figure out the phase shift is 1/9 pi. And it shifts which direction, to the left or to the right, if the phase shift is positive.
To the left.
So,
Wait, but it's negative.
sorry, it is, so it's to the right.
To the right.
And so if I started sine and I shifted it to the right, and sine, it's a positive amplitude, so it starts at 0, 0, right? Goes up and then comes back down. And if I shift it to the right, this one looks like it's shifted to the left. Oh, and it's also shifted up 1, isn't it?
So then it'd be C.
Oh, it's got to be these two. These are the two I'm looking at. Yeah, I think it's this one. Because you've got it, the midpoint here. What would be the midpoint is shifted to the right 1/9. Okay, find the amplitude of y equals 9 cosine theta. Amplitude's 9. And then graph.
So it's either B or A.
Yeah, there's... I'm confused with the letters. Is this
The
this is
letters on
B?
the last one are on the last page. Or the letters
So this is A.
Yeah.
Okay.
And it said A's amplitude
Was 9, and the other one does not exist. Okay, so it's the one of these two. And it should, what's the period? 360, so it's got to be this one. No.
It would be the bottom.
No, it's the bottom one. Yeah. Because this goes through twice in 2 pi. Yeah. This is painful.
I agree.
Okay. So the best way to do this one is, first off, I know that's going to start at 11 and negative 11, right?
Yes, ma'am. So C is out of the question.
C is out of the question, yes. Let's see what B and D show me.
D is out.
B could be in. So it's A and B. What else do I know? 1/5. So 2 pi over 1/5 is 10 pi. So it's going to be elongated,
So the next one.
right? So it's got to be this B. God, why do I want you to know these so well? Just kidding. Tangent. Okay, tangent starts right, goes left. Its period normally is pi, so it doesn't change. The period's still pi. The phase shift is 30 degrees left. So far, amplitude with tangent and cotangent really doesn't exist. All it does is stretch it. It doesn't, I mean, it's not like it, I don't know how to explain it, but it's usually for amplitude with tangent and cotangent does not exist. So it's C or D, and let's see. This has a phase shift of 30 degrees, which looks like that would be D. So I'm thinking it's going to be C, but let's look at D. Well, let's look at... So one has a phase shift of 30, and the other has a phase shift of negative 30. So it's this one.
Negative 30.
Yeah. Does this have a period of pi?
Yes.
Yeah. Does it?
Yeah, it says period 180.
Oh, yeah. Okay. All right. Cosecant is going to be the one that goes along with sine. This one then is going to have a period of 2 pi, 4 pi, 4 pi, which is going to lengthen it. 4 pi doesn't give me any numbers on this one. When it's plus 2 pi, that's really not going to change anything, is it? Well, it might, because it's 4 pi now. 4 times 180 is, oh, this is 4, let's do times pi. 12.56 is how long it takes to repeat. So sine 0 pi over 2 pi 3 pi over 2, 2 pi, right? But now, my new values, because it's now 4 pi, are just going to be doubled. So it's going to go pi, 2 pi, 3 pi, 4 pi. And if it shifts by 2 pi, I'm going to be subtracting 2 pi, right? So this becomes negative 2 pi, negative pi, 0, pi, 2 pi. Those are going to be where my key points are. And now for my y values, sine of 0 is 0. Then it goes to 1. Then it goes to 0, negative 1, 0. Right? So if I were to graph sine with this function, I would start at negative 2 pi, 0, and I would go to 1, back to 0, negative 1, back to 0, and then this would be 2 pi here. Okay, so my cosecant should have its bottom line at pi, or negative pi. So this one is the one it looks like. That makes sense? That's about 3.14, which is, so this is graphed in radians along the x-axis. It's easier for me to graph sine and then just figure out where the parabolas go. Okay. Graph, oh, did we do inverse trig functions?
I don't think so. I don't really know. I don't even know. I might have just guessed on the sheet.
I'll just throw this one out. I don't know if we even graphed inverse trig functions in this year. Okay. Let's go on. Okay. Find the value of cotangent of inverse cosine of negative 1/2. Cosine's negative in this quadrant or this quadrant, so let's just make it here. Where, and now, so this is really theta, right? Where can inverse cosine exist? First or second quadrant. It can't be in the third, right? Because we have to restrict the domain from 0 to pi. So this is my angle, and it's negative 1 over 2, so this is the square root of 3. And cotangent of this angle then is negative 1 over the square root of 3, which is negative square root of 3 over 3. Given a triangle with A is 14, this is A, sorry, A, B, C. A is 14, angle A is 41, angle B is 34. So we want to find the length of C. Well, I can figure out this angle, because that's what, 75? 5 is 105? Is that right?
Yes.
And so I can just take sine of 105 over C equals sine of 41 over 14. So sine of 105, no, let's go, yeah, that's right, times 14 divided by sine of 41. So I get 20.6. We'll call it this one. No, this isn't the right triangle. Where are my answers for the previous one?
I think they're on the
Okay, what am I doing?
It's number 25.
Oh, 20.6. Okay. Now we're trying to figure out if the next one needs to be law of sines or law of cosines. If A is 19, B is 20, and C is 63, law of sines or law of cosines?
cosines.
Yeah, because I don't have the other two angles, so I don't have the side opposite the 63. So this squared is 20 squared plus 19 squared minus 2 times 20 times 19 cosine 63. And just plug all that in your calculator. So 20 squared plus 19 squared minus parentheses 2 times 20 times 19 times cosine 63. And then take the square root. 20.4 for C. Could be either, no, it's, yeah, D. Okay. Find the area of the triangle. It's 1/2 AB sine C.
Something like that.
Who remembers how to do it with a, if you were given points, how to do it with a matrix from Algebra 2?
I wish I remembered that.
But we're not given coordinates. So we have ABC. B is 4. C is 12. I don't have an angle. So I need to find an angle? Or can I? What's the formula here when I just have the sides? Do you guys remember?
I don't remember. This was one of my resource questions as well.
If I know the angle between them, it's 1/2 AB sine theta. And this is not a 3, 4, 5 or anything like that. So I'm going to have to find an angle using law of cosines and then use 1/2 AB sine theta. So I'm just going to pick one of these. Let's pick this one. So I would say 10 squared equals 12 squared plus 4 squared minus 12, I don't know why I put that in parentheses, minus 2 times 12 times 4 cosine x. So I take 100 and I subtract 144 and subtract 16. I get negative 60. 12 times 4 times 2. Then I take negative 60, divide it by negative 96. Take the inverse cosine of that number. And so this angle is 51.32. So now I take 1/2 AB, this is A and this is B, sine of 51.32. So I'm going to take sine of that angle times 12 times 4, divide it by 2. I get 18.7. I'm just happy my answer's up there. Does that make sense?
Yeah.
So I use the formula 1/2 AB sine theta. And theta is between the A and B. Okay. See how much time I have? I'll put this in Canvas part 1 and part 2, basically. Cosine theta is equal to 4/7 cosecant is less than 0, which means sine is less than 0. So that tells me cosine's positive, sine's negative. That happens to be in the fourth quadrant. So here's my angle. Cosine is 4/7. And this would be, what, 49 minus 16? Negative. So find sine and tangent. Sine should be negative square root of 33 over 7. But it's not negative there. That's weird. Because it's got to be less than 0. Cosecant's less than 0. So sine must be less than 0. So there must be a typo on that one.
But tangent then should be negative 2.
Right, right,
That's also the only answer.
right. So I think this is, I mean, this has to be the only one, but they both should be negative. If you get a question like that on the test and you think you're right, then just ask me and then I can let you know. Okay. If secant is negative 1.2, so that means cosine is, that's 5/4, right? Cosine's 4/5, negative 4/5. So I'm just going to write this. So this must be 3. This is theta. So if I'm going to take this angle and I'm going to subtract 90 from it, right? That means that this angle, these switch. This is 4 and this is 3 for that to be 90. Does that make sense? If I was subtracting 180, the triangle would stay the same. You just have different signs. If I subtract 90, let's say this was 30 degrees, reference angle. That means this is 60 and this is 30, which means this is a 60 degree, which is why I switched my x's and y's. So I'm trying to find sine of this angle would be 4/5, which is not up there, 0.8. I don't know why it's 0.83. So, oh, it's secant. No, I did secant. It's 5 divided by 4. Oh, 5 divided by 4 is 1.25. What's a fraction? It's a fifth more, right? So it's 6/5. Yeah. That's why. So this is not, this is 36 minus 25. So that means that this is 5, this is square root of 11, and this is 6. So sine then, 5 divided by square root of 11, sorry, 5 divided by 6, right? 0.833. Losing my mind. Okay, now on to some simplifying. Cotangent, so this cancels. Cosine x minus cosine x is 0. I'll do one more if I can, and then we'll be done with this until tomorrow. So I'm going to multiply, this is sine x plus, minus 1 plus sine x plus 1 in the numerator. And in the denominator, I have sine squared x minus 1. So this cancels 2 sine x. And this, if I take a negative out, I'm left with 1 minus sine squared, right? And this is cosine squared. So I have 2 sine x over, there's a negative now, cosine squared, which is tangent to tangent secant negative. That makes sense? Because sine over cosine is tangent, and then I have an extra 1 over cosine, which is secant, and I have a negative 2 in front. Okay, we'll start on 32 tomorrow. How many questions were there?
45.
Okay.